Right. So this is a quick little video going over some of the concepts of 10.1. Chapter 10 is all about circles. And first we're going to take a look at some vocabulary, some old vocabulary, some new vocabulary, and an example problem involving the main theorem from 10.1. All right, so, well, there's a couple theorems in 10.1, but we'll take a look at a couple. So first, some vocabulary, some old vocabulary first. Circle, obviously, excuse the crudity of my drawing here. I don't have any construction equipment with me here, my home. Circle, a set of planar points, so it's on a plane, it's 2D. The 3D version is a sphere. We'll talk about that later. Where is an infinite set of points, all equidistant from a center. So the center is always drawn in with a nice big old dot. The old vocab is, of course, the segment that goes through the center from 2 points to the circle. Through the center is the diameter, and then a segment that goes from the center to some point on the circle is just a radius. The plural is radii. Okay, that's old news. Now for the new fun stuff. We have a line that touches the side, outside of the circle at exactly 1 point is called a tangent line. The point where the tangent touches the circle is called the point of tangency. And one of the theorems from this section is that the tangent line is perpendicular to the radius that intersects at the point of tangency. And we're going to use that in an example here in a second. So a tangent line, again, just a line that touches the outside of the circle at 1 point. A secant line is a line that touches the circle at 2 different points, and the whole line itself is called the secant, but specifically the part that's inside the circle is called a chord. So a segment that, the portion of the secant that's inside the circle is called the chord. Okay, so our first theorem is that when you have a circle and some point of tangency, that radius is perpendicular to the tangent line at the point of tangency. So radius is perpendicular to a tangent at the point of tangency. So we can use that for an example problem like this. Because of this theorem, and we have that perpendicular segment there, the radius perpendicular to the tangent at the point of tangency, when we have a scenario like this, we create a right triangle. And we all know with right triangles, we get to use our most excellent Pythagorean theorem. Now, I'm going to do an example of the hardest version. You guys know how to use the Pythagorean theorem. But this particular version is when we are looking for the radius of the circle. So the radii are both congruent to each other, so we have 2 different x's here. And I know that this portion of the tangent is 32 units, and this portion from the circle to this point is 16 units. And we don't know the radius, but we do have the Pythagorean theorem. So the entire hypotenuse here is x plus 16. Now these parentheses are actually important here. The c squared equals a squared plus b squared. And you'll see why in a second. is an algebra concept that we're going to have to practice a bit. So it's called binomial distribution, or foiling for short. Foiling is just an acronym that describes all of the partial products you have to do. And I don't know what 32 squared is. Let me use my old calculator here. All right, so foiling stands for first, outer, inner, last. So when you take the product of the two first terms, it's a foiling or binomial distribution. It's kind of like a double distribution. You're distributing the x into the set of parentheses and distributing the 16 into the set of parentheses. So x times x is x squared. And then we have the outer, x times 16. And we have the inner, 16 times x. And then we have the last, 16 squared, which I believe is 256. Let me just double check. 256. All right. When you FOIL, well, not always, but typically when you have an x term and a constant, you're going to have two like terms here in the middle, so which we can just add those two guys together. Okay, and in a future video coming up very soon, I'm going to show you how to use the quadratic formula. But lucky for us in this particular problem, when you combine like terms, you can subtract an x squared from both sides, and that x squared completely goes away. So now you only have to deal with a normal old x. So we'll subtract 256 from both sides. I'll use my calculator here. Not feeling the mental arithmetic super strong right now. So that's 768, and does that divide evenly by 32? It does. Sweet. So, yeah, again, the theorem, tangents are perpendicular to the radius at the point of tangency, and that allows for some super fun Pythagorean theorem problems. And in particular, one of the new skills we're learning here, in addition to some new vocabulary, is binomial distribution, foiling for short. And we'll deal with the opposite of the distribution, the factoring, with the quadratic formula, probably in a video for next week. I didn't assign any practice problems this week that require the quadratic formula, but next week we'll take a look at a few. All right, and the next theorem is about two external segments of a circle that have a common endpoint. Something like this. I'll keep drawing those, a common endpoint there. So when you have two segments that are both tangent to the circle, what we're going to see is that they are congruent. So I'll just write that there. This is a theorem. Okay. Two tangent segments with a common endpoint are congruent. And that leads us to the other types of problem from the 10.1 anyways. Excuse my less than perfect drawing. But if we have some situation like this where we have those two tangent segments with some common endpoint here, we're basically just going to take whatever algebra expressions they give us and set those two bad Larrys equal to each other. So if I had like a 28 meters here and a 3x plus 4 meters here, for example, the key is, oh, hey, these guys are congruent. We can set these two expressions equal to each other. And then, of course, just go ahead and use a little algebra and solve for your variable. That's pretty much that. All right, so that's pretty much 10.1 in a nutshell. A couple new vocab words. Take a couple minutes to study the vocab, chord, tangent, secant. And then the other new skills is, well, the theorem about the perpendicular tangent and radius at the point of tangency leads to some Pythagorean Theorem problems where you are going to have to use binomial distribution or foiling. So that's going to be a new skill there. Well, maybe not totally new, but you got to practice it a bunch. And then the other theorem that the two exterior portions of tangents that share a common endpoint are congruent. So in that situation, you just set the two algebra expressions equal and then solve away. Okay.